All right, so these notes are going to be basic word problems that we have to change into an equation and then evaluate. So make sure that you're taking detailed notes, and then you will submit the notes as a PDF to Google Classroom. So let's start off by reviewing. Remember that exponential functions are y equals a and then b to the power of x. So let's take a look at what a is. A represents that initial amount, which is the same thing as the starting value. It's the y-intercept, it's the y value when x is 0. So all of those things are a way for you to identify the a. Now the b value is going to be the rate of change. In a sequence, if we are multiplying by the same number, that is going to be what the b value represents. Now, there's a couple of things that you need to know about the rate of change. The rate of change can either be a growth or a decay. So a growth is going to have something that looks like this, where it is increasing, like it's growing up, and a decay is going to be where it is decreasing, where the y values are going down, okay? So there's a couple of extra little things that we should make sure that we can associate with both growth and decay. So first of all, if it's growth, the b value, which is the number that is being raised to the power, that needs to be bigger than 1 in order for it to be growth. Decay, on the other hand, needs to be a number in between 0 and 1. And then there's very common in exponential functions, there's what we have a percentage rate, okay? And if you have a percentage rate that is positive, that's going to be growth, right? So if you can identify if the function is growth, then that means your percentage rate is going to be positive. Whereas decay, the percentage rate is going to represent a negative. Okay, so like when you buy a car, that is a negative growth rate, right? As soon as you drive it off the lot, the value of the car decreases. Okay, so let's take a look at some things regarding percentage rate. It's going to be a percentage, which means you must convert that to decimal form. So the other thing we need to consider is finding the b value, because sometimes the b value, especially in a word problem, is not always so easily identifiable. A lot of times, especially in percent word problems, they give you the rate of the um, dealing with a word problem. And so they'll give you like the percent rate. And what you have to do is take that percent rate and find the b value. So the way to do that is to understand that the base is going to be equal to 1 plus the rate. Now, sometimes that rate, again, we talked about, if it's growth, it's going to be positive. And then if it's decay, it's going to be negative. So sometimes we're going to be adding the rate, or sometimes we're going to be subtracting it, depending on if the rate represents growth or decay. So let's take, for example, number 1. A town has a population of 11,000. And grows at 4% every year. What will be the population after 15 years to the nearest whole number? Very important to learn how to mark up the text when it comes to word problems. So we've got some numbers and some context here. You always want to read through it twice and then be able to identify some numbers. So a town has a population of 11,000 and grows at 4% every year. And then what will be the population after 15 years? And we want to go to the nearest whole number. So what I did was I am reading the text, circling some key terms, some key numbers that I need to make sure that I'm accountable for in my problem. So let's take a look at the steps that we can apply to every word problem. So number one, the first thing you always want to be able to do is to identify the variables, the A, the B, and the R. Sometimes you won't have a rate, and that's fine. But you still want to be able to identify all of those variables if you can. So when we go and identify the variables, let's go through and identify those variables real quick. So again, the A is going to represent the initial amount. So in this word problem, are you able to determine what is the starting amount? In this particular word problem, what would that number represent? So hopefully you guys can see that the starting amount in this context was 11,000. It says a town has a population of 11,000. And then it grows at 4% every year. So let's take a look at the B value. Now the B value is that rate of change. Well, in this case, I don't know what that is right now. It's not very clear. This right here is a percentage rate, and this 15 years is about time, and I'm not even there yet. So let's take a look at the rate of change. We don't know. Let's take a look and see if we can find out the R. Well, the R is the percentage rate. It's 4%. And it's positive because it says it grows. All right. It grows at 4% every year. So that means it's a positive 0.04. Remember, we always have to have it in decimal form. So this is representative of step one. Okay. So hopefully you were able to identify the A, the B, and the R. Let's see what step two is. Step two says find any missing variables. Well, my missing variable, and that's my dog squeaking his toy, my missing variable is my B value, right? Because I don't know it, it's a question mark. So if we go back up here to the notes, it even says right here to find B, use that idea. It's the 1 plus the rate. So what we're going to do for step two is to calculate that B value. So now it's 1 plus that rate of 4%. And so that gives me my 1.04. So now that I have my A, the B, the R, I'm going to be able to create the equation. So remember that the equation was AB to the X. So in this case, my A, right, which was my starting amount, is what goes here. My B value was what I just found as 1.04, and it goes to the power of X. So we needed to be able to just get the A and the B. And then the last thing you want to do is evaluate the equation and round if necessary. So in this case, I'm going to use a calculator. I need to do order of operations first. So when you do that, you are going to calculate this number first, and then you are going to take that number and then multiply it by 11,000. So when you do that, you get this number. Please make sure that you're getting that number in your calculator. And then it did say in the directions to round to the nearest dollar amount. So it says to the nearest whole number. Sorry, not dollar amount, but just to the nearest whole number. So I've got this, and then I always, when you round, you've got to look to one more than what you need to go to, and then that number is going to tell you what to do. So since this is a 3, that means I get to stay. Remember, if it's 5 or higher, you have to go up. Okay, so in this case, my final answer is going to be 19,810 people after 15 years. Okay, all right, so now let's take a look at this one. I want you to try it. I'm going to ask you some questions on the Ed puzzle, and then we're going to go over that. Okay, so let's go ahead and take a look at reading and marking the text. We've got a new car, and it's purchased for $20,700. The value of the car depreciates at 11% per year. What will the value of the car be after 11 years, round to the nearest cent? So again, always want to go back and read it twice. So we've got a new car is purchased for, we're going to highlight or circle that amount. The value of the car depreciates. That's a very key word. So depreciates, it's kind of like you're decaying. It's getting less valuable every year. And then there's the 11%. The question says, what will be the value after 11 years? So we want to highlight that. And then we also want to kind of highlight or circle the nearest cent. So from here, let's just make sure that you can identify step 1. Can you identify the variables, the A, the B, and the R? Okay, so A again is the starting amount. So hopefully you were able to identify that as 20,700. The B value is the rate of change. I am unable to determine that right now based on the given information. And then the rate is the percentage rate, and it was 11%. However, this is where you need to pay careful attention. This is super, super important, that the depreciate represents decay, which is going to make your 11% a negative. Okay, so make sure that you understand that that's a negative rate. So then remember, if you, step 2 would be to find anything else that's missing. So we need to find our missing variables, which means our B value is 1 plus the rate, which in this case is 1 plus a negative, which means when we simplify that, we get a 0.89. Now this does, I want you to check to make sense before we move on. Because this should be a number less than 1 if it's decay. If you had a number bigger than 1, that means it would be growth. And the fact is, in this particular word problem scenario, we should know that the value of the car is getting smaller and smaller and smaller as the years go on. So just always kind of make sure that you're getting things right as you go along. It's a good way to check. So now we're going to take this information and put it in the form of an equation. Right? So there's our initial value and there's our growth rate. And then step 4 is just to evaluate, which means I'm going to take my equation. It said that how much is it worth after 11 years, right? So 11 years is going to be what I put here. And remember that that's the number of years. It's not the rate. It's just happened to be another 11 in the problem. And then calculate this. Very important that you do this number first, right? Because of PEMDAS, which means exponents comes before multiplication. So we get this number and then we multiply by 20,700. And then what we're going to do, again, read round to the nearest cent. So instead of whole number, what we're going to do is round to the nearest cent. Let me just zoom in real quick. We know that that's our dollar amount. We know we need to go to 60 cents, but we have to look at 1 over from where we need to be. That 8 is going to tell this 0 to go up. So the proper way to phrase this now, after 11 years, the car will be valued at $5,744.61. All right, so what I would like you to do is to try some of these on your own. And then I'm going to talk you through the ed puzzle. So a new car is purchased for $20,700. The value of the car depreciates at 13.75% per year. What will be the value of the car to the nearest cent after 12 years? Okay, try that. Let's see what kind of value you get. All right, so again, step 1 is, well, first we're going to make sure that we understand that this is exponential, but step 1 is to identify all of your variables, right? So A, the starting value was 20,700. Did not know my B value. The rate is 13.75%, which in decimal form is 0.1375. The next step would be to find the B value, right? We have to find our missing term. So what we are going to do to find our B, it's going to be what I want you to make sure this rate, we said depreciates. So instead of, that's just the decimal form, but remember the rate really is negative 0.1375 because of the word depreciation. So to find the B value, it is 1 plus the rate, which is 1 plus negative 0.1375, which is what this means right here. And you get 0.8625. Now think about what this is saying. It's saying B equals 1 minus R. The reason why they're saying that is because if I give you a 1 plus a rate, but the rate is negative, if I were to simplify that, I would have 1 minus R. That's where they're getting this. They're just simplifying those double negatives in advance, okay? We still ended up with 1 minus 0.1375. Rewatch the video if you need to for further clarification. Okay, all right, so now let's take a look. We now put our function into the proper form. Okay, so we want to be able to write our equation. Then now it says 12 years. So now what we're going to do is we're going to evaluate. So in place of x, we put 12. Order of operations says you do that calculation first, and then multiply it by 20,700. This is what you get when you calculate that in your calculator, and it does say to the nearest cent. So pay attention. We want, this is the dollar amount and this is the cents. Now we need to look one over, and it looks like I'm going to stay the same. And so that's going to be my final answer. So hopefully you guys did that good. Okay, try it again. See if you can answer all the questions on the Ed puzzle. Okay, so again, we've got our exponential function. Let's go ahead and read and highlight or box or circle. Let's identify those key things. It says an element with a mass of 330 grams decays by 25.5% per minute. How much of the element is remaining after 5 minutes to the nearest tenth of a gram? So always read it first. Second time through, we mark it up. So an element with a mass of 330 grams, and it decays, and it's by 25.5% per minute. How much of the element is remaining after 5 minutes? And we need to go to the nearest tenth. Okay. All right, so let's take a look and see if we can identify our variables. So my A value is 330. I do not know my B. My B is not given. But I do know that my rate is 25.5%, which we need to clarify here because of the word decay, means that my rate is negative 0.255. Okay. Now I'm going to use that to find my B value. So my B value is going to be 1 plus my rate. Remember that when you have signs back to back, a positive and a negative, the negative is going to win. So 1 minus 0.255. And then let's check that calculation. This is what we get. 0.745. Okay. Again, why is it 1 minus R? It's 1 minus R because my rate was negative. Remember, it's 1 plus R. In this case, my rate was negative, so it's 1 plus a negative R, My rate's negative. So when I simplify that expression, I get 1 minus r. So for decay, you will notice that it's 1 minus r. All right, we still ended up getting there. 1 minus 0.255, which is 1 minus 0.255. So just want you to see that correlation, that is the same. Okay, so now that we have all of that information, we got to put it all together, right? We got to come up with our equation. So there's my A value and my B value. So we're just going to put that all together. And then now we need to evaluate. So when we evaluate, we just plug in. Remember it said after 5 minutes. That's from the word problem, after 5 minutes. Again, do this calculation first in your calculator, then multiply it by 330. And then we're going to go back and read. It says nearest tenth, which means our nearest tenth. That's going to be our whole number. We want to go to 0.7, which means we got to look at the 3 to determine if the 7 is going to go up or stay. So we're going to go round, and then that's going to be my final answer. All right, last you try problem. Town has a population of 12,000 and grows at a 3.5% rate every year. What will be the population after 7 years? To the nearest whole number. So let's make sure that you can answer the questions that follow. All right, we are going to highlight and read again. A town has a population of 12,000. It grows, keyword grows, 3.5%. What will be the population after 7 years? And it says to the nearest whole number. All right, so make sure that you identify those keywords in here. All right, so let's see if you can identify the A value. The A is the starting at 12,000. We do not know our B, but we do know our rate. Now, the question is grows. Grows means the rate is going to be a positive 0.035. So decay means it's going to be a negative. So what we're going to do is represent our B value. Remember, our B value is 1 plus the rate. In this case, we end up getting our B value to be 1.035. Okay. So that's our B value, that's our A value. What we're going to do is put that into the form of an equation. Okay. And then now we are going to evaluate. Time is 7 years. So when we evaluate, we plug it in. There's the 7 for the 7 years. Do this calculation first, then multiply by 12,000, and that's what you're going to get. And now we need to pay attention to the nearest whole number, which says we want to go here, which means I look at the 3. The 3 tells me that I need to stay.